In experiment 5, we're going to be looking at different types of chemical reactions. So first of all, we need to understand that a chemical reaction involves breaking or forming new bonds and forming new substances, as opposed to a physical change where there's no new substances being formed. A chemical change is the same thing as a chemical reaction. And we abbreviate reaction rxn. That's a very common abbreviation. Let's look at how we represent a chemical reaction with a chemical equation. Here's an example of a chemical equation. Each of these is a chemical formula. Each reactant is shown as a chemical formula. This particular reaction has two reactants. And after the arrow is where we put our products, and this reaction only has one product. These coefficients in front that are in red tell us the amounts of the reactants and products involved. Notice that there is a coefficient there of 1. It's not shown. We also have state symbols in our reaction. The state symbols tell us what form of each reactant or product is present. Of course, S is solid, G is gas, L is liquid, and aqueous or aqueous, either way, means dissolved in water. So often, aqueous reactants or products just look like water. They sometimes are colorless, sometimes they have a color to them. But we don't call them liquid, we call them aqueous. Okay, so that's some basics. Here's some of the terms that were from our objectives. And reactants and products, we've already talked about those. Those are what you have before and after the reaction. A precipitate is a particular type of product. Notice in this reaction we have two aqueous solutions coming together. An aqueous solution is not cloudy. It's clear. You can see through it. One of the products is an aqueous solution, so we don't see that one. But this product is a solid. This is our precipitate, and we abbreviate precipitate PPT. Now, how you'll observe this is if you mix these two solutions together, they're clear. If this solid forms, it will form like a powder within that. It'll make it cloudy. So today in the lab, when you mix two clear solutions together, if you get something cloudy, some powders that form in there, and sometimes they're white, this one happens to be white, sometimes they're yellow or different colors, that cloudiness is caused by a solid product, a precipitate. Okay. Next thing I wanted to talk about with this equation is that notice it is not balanced. And let's talk about what balanced means. Okay, so if we balance it, what we do is we change the coefficients so that the number of atoms before and after the reaction are the same. And we need to look at the number of atoms and the type of atoms. And in this reaction, as written, chlorine is not balanced. The reactants only have 1 atom of chlorine, but the products have 2 atoms of chlorine. So we would say that it's not balanced. When we balance, the only thing we can do is change the coefficients. We don't want to change these numbers down here. These are the subscripts, and they identify the substance. So never change the lower numbers to balance it. You always change coefficients, only the big numbers in front. So by putting a 2 there, I've balanced chlorine. Let's look at what else that just affected though. Now I have 2 potassium atoms in my reactant and only 1 in my product. So I'll add another 2 here, and that gives me 2 potassiums. On this reaction, because the polyatomic ions remain intact, you may recognize the NO3 as nitrate. That remains intact. This has 2 nitrate polyatomic ions, and in the reactants I had 2 as well, so nitrate is balanced. There's 1 lead in the reactants and the products, so now that is balanced. We'll balance some more here in a few minutes and do some predicting products. But anyway, that's the idea of what balancing means. Next term is catalyst. A catalyst is something that speeds up the reaction but is not used by the reaction. If you remember it from lesson 4 online or in class, it lowers activation energy. Let's say lowers activation energy. If we have a catalyst, we can put it over the arrow. And in this reaction, I know that platinum, a metal, is a catalyst for this reaction, so I can put that over the arrow. Remember that an enzyme is a biological catalyst. So in your body, you have enzymes that are catalysts for your reactions, and so often we'll have enzyme names over the arrows in biology. A type of reaction we'll be studying quite a bit is the neutralization reaction. You need to know the general form of a neutralization reaction. Acid plus base yields salt plus water. Notice that the salt doesn't have to be table salt. It does not have to be sodium chloride. Salt just means ionic compound. Metal and non-metal. Sometimes they have a polyatomic ion in there, but anyway, ionic compound. These reactions are double replacement reactions. We have 4 general categories of double replacement, 4 main classes of chemical reactions, which we'll cover here in a minute: combination, decomposition, double replacement, and single replacement. And neutralization falls under the category of double replacement reactions, and we'll see why here in a minute. We'll do another example. Another type of reaction is the redox reaction, and this is not, and I say redox like this, this is not one of the 4 major classes. It's another type that can overlap into the others. Sometimes single replacement, decomposition, combination reactions are redox. Double replacement reactions are never redox. Anyway, so this is one definition of redox reaction. This is for inorganic chemistry. This is dealing with ions and metals. So redox reactions can be inorganic or organic. And in my class, I deal with the organic type in the lecture part of the class, and I just hit the inorganic type in lab. In the inorganic type, oxidation means losing electrons and reduction means gaining electrons. These two reactions occur together, oxidation and reduction. And in fact, it's really one chemical reaction. What's really happening is that one reactant is giving electrons to the other reactant. Let's look at an example redox reaction. So, which reactant is gaining electrons, aluminum or oxygen? Well, the first thing I need to tell you is that when we see aluminum like this by itself and no charge is shown, that means its charge is 0, it's neutral. Oxygen here, again, it's in the -2 column on the periodic table, but that's when it's in an ionic compound. When it's by itself, its charge is neutral, it's 0. Now, here's the aluminum and oxygen in an ionic compound. So then we can use the periodic table to figure out that aluminum must be +3 and oxygen is -2. So now we can look at the charges and see which element is gaining electrons. Remember, electrons are negatively charged, so we look for the one that is becoming more negative. That one's gaining electrons. That means it's being reduced. So oxygen is being reduced. I like to remember reduction is meaning a reduction in charge. When it goes from 0 to -2, that's a reduced charge, so it is being reduced. And then if we look at our other reactant, aluminum is going from 0 to +3, so it is it's losing electrons, it loses electrons, so it's oxidized. Again, you'll always have one reactant oxidized and one reactant reduced.